Hello guys, welcome back to another video from my channel. And in this video we're going to discuss how to download digital elevation models, calculate aspects, slope, hillshade, and the next part of this video we will see how to classify satellite images and to Google Earth Engine Explorer. So let's go. I can start by the name of Allah. So here I click here and SRTM data, as we talked in the previous videos about the importing different type of images, satellite images into the workspace, and applying indices, downloading the data. So now let's see. Digital elevation models. So you can check your data in this list here, and you can choose the data according to your uh, purpose of project, according to your study area, and it will be specified by your necessity, by your choice, by your purpose of your study area. So how I select it here. So let's see. Using digital elevation model from Google Earth Explorer, and one of the good things can be considered here is that uh, if you want to download the digital elevation model for a specific area using other sources like USGS website. So in that case, you need to download many pieces of SRTM images or SRTM rasters. Then it is really will be hard and confusing to select the pieces and the study area to be covered by the selected pieces. But uh, in the Google Earth Engine Explorer, you didn't need to do that. Just you can download what you need. You can select the area and just by selecting or by drawing a polygon, you can download what you need from this platform, whatever you need, and wherever you want, depending on your study area. So for example, I'm going to download the digital elevation model for this area. So Taloqan city of Afghanistan. It's exactly a livable city. Now when you have loaded your data, so you can click here by clicking this. Your your download option will be will be ready. So in here, this option will give you the choices to select how do you want to select your downloadable area. Your viewport is your screen size and the data zoomed, and your screen size label will be downloaded by drawing a rectangle. Just you can draw a rectangle, and for example, you want to download this area, or you want to draw a polygon just like this. So by drawing a polygon, you can specify the regions and the bottom, zone the area to be downloaded. And here you must specify the bond, which bond you want to download it. So in this part, you can specify your coordinate systems. So you can select as native VGS 84 or any of these coordinate systems are available here. And in here, you must specify your resolution. In this option, you must be aware of the quality of your data. So spatial resolution of selected and loaded data must be uh, the same as here to obtain or to keep the original resolution of the data. And finally, you can collect the data and your data will be downloaded here. Uh, After that, you can open this downloaded data and use in any other GIS and remote sensing software. So I'm going to open the data into the INV very correctly. I extracted the data. Now I can go to the download folder. So SRTM digital elevation data version 4, yeah, as it's here. So now you see here, and you can use this data and your studies. And also, it's very easy, very easy to calculate the sloping aspect in the environment of Google Earth Engine Explorer. So you can click here, select the option that you want. You can select your image. Uh, Digital elevation model. Then uh, visualization. You can select the visualization. RGB or grayscale bonds. So then you can click on save. The calculation will be saved here. The image you see here is a compound of uh, aspect and slope. So whenever you want to download, you can select which bond must be downloaded, aspect or your slope. For example, when I click here, you see this is in RGB uh, composition visualization. So the first bond is slope, the second and the third bond is slope. So even you can select three of them from when that you can see the range of the slope from 0 after 90 degree, or you can select the single line and aspect as you see from 0 up to 359 degrees here. Whenever you want to download one of these slope or aspect from your workspace, then you can select here which one of these bonds must be downloaded or you want to be downloaded. For example, I'm going to download that slope. Then I can select that area of my interest and I can download this area. And also uh, we can calculate the Hell sheets of the Hell. So it's very simple and very easy. So you can select your input image. So if you want to rename any process, any calculation, any expression, uh, you can rename this here. For example, I'm going to the Hell sheet is okay. Computer layer is not necessary here. So save. And now we have the calculated Hell sheets here. And you can select any parts on the map to be downloaded. So it would be your choices. So this was that how to download them or calculate slope and aspect and Hell sheet. I'm going to mention one thing here. The capability of the Google Earth Engine Explorer is not as high as much as Google Earth Engine. It is a coding platform. But these are the beginning of the steps. Maybe within next 2 or 3 years, even we don't need to use graphical application in our systems. And the systems like Google Earth Engine Explorer or itself will be suitable and enough for uh, any of analysis in application. And just these are the first steps. You must keep your connection and get familiar with this type of systems because it's going to be our future systems, our future approach to process the image and use to modeling to my spatial analysis. So any other spatial based processing. And now I'm going to close all these layers. Now let's see and apply a classification on to see how to work, how it would be. From here, now I'm going to select a Lancity 832 this data or image. Mm, which one must be selected? If it was an online class and uh, I should decide to ask you to help me in selecting. Mm, I'm going to find 32 Ds. TOA reflectance. Lancet 7, Lancet 8, collection 132. NRBT, Lancet 4, BAI composite, NDVI. Oh my god, where is this? NDBI, NDBI composition, Lancet H32 TOA reflectance. I'm going to use this image for this purpose. Now you can see here, I'm going to change the color composition for beta visualizations. B5, B4, and B3. And I'm going to apply a 90% of stretch. So now I apply this. Let's see what happens. Oh my god, it's great. So now I can save it. And I zoom into the study area. Now I'm going to use this image for image classification here. Look, from this, the search box, I'm going to select hang the round points and polygons here. So I have some classes here. Now I'm going to delete all these classes. And now I can add the classes. You can select or specify the number and the type of your study area classes based on your study purpose and your study area. Which classes your study area provides or can be provided by your study area, and what you need in your processing or in your research. So these are the two key points that specifies your class numbers and your class types. In this study area, we have a river quite uh, inside this vegetation covered area, so it would be great to select a class under the name of the water, and this area has bunch of vegetations, so a class can be created by the name of vegetations, and the other classes can be specified by the name of bare soil or unvegetated area or any of these. So the first class is going to be vegetation. This is my first class, and second class is going to be soil, and the third class is going to be water. Yeah. So now I select the vegetation and turn off this layer because the quality of the Google Earth engine map is better. So now I select some training points for my classification from this vegetation covered area. This is just a tutorial, to show you how to do or to help you for applying or carrying each of the steps. But when you are doing a real classification, just remember this to select your ROI or your training sample from all area, or your training sample must be divided or distributed into all your study area. Just it's a sensitive process, quite like uh, distribution of any other statistical process. 16, you can see the number of points here. So how many points or training samples that you have selected? I think it's enough for me, 20. And I'm going to select the next one. And this is the soil. Now it's 9 points from these areas. 16, 17, 18, 19, 20. So now the water, I have to zoom into the, oh my gosh. It's really difficult to classify this water into the water, because of the color of the water. And the reflectance of this water is quite similar to the soil. And because of the water pollution, or the pollution of the water, or the composition of the soil into this water. Anyway, we don't have any other choice. We have to select some ROIs from this. We are going to train our classifier by these training samples. I'm going to select 10 training sample would be okay for this one, 11, 12. Okay, it's enough. And now I turn on the satellite image. I'm going to apply my classification now. So when I click here, these are my sample points. Okay. First off, this step, I'm going to change these colors. The soil must be yellow. The color for the water is okay, and green for the vegetation covered area. This is my input image here. So you can change the interval of the dates if you didn't get a feasible result of application classification. So in here, you have terrain classifier. We're going to teach our classifier method, or we're going to train our classifier method, or our classification method by these training samples will tell the classifier that any reflectances similar to this that are selected vegetation must be considered as vegetation. And those pixels that have similar reflectance like or similar values like soil 20 points that we have been selected must be considered as soil and as well water, the water. And from this option, you can select your classifiers. We have three classifiers here: random forest, cars, naive Bayes. And even you can apply three of them to see which one of these classifiers works better or give you a better result. So let's try by starting the first one. Now, I can click here to train classifier and display the result. It's really a bad classification, you know. This exposed only 25% of 100% of the soil are classified as water, and 100 of the waters are classified as water too. 95% of the vegetation are classified as water. It means 95% of the area is classified as water according to the bias. It's, it's boring. So let's try the next one. Cart. Oh, yeah. This exposed a feasible classification result. You can see here. Still, we have many commission and omission errors here, but at least it's better than naive Bayes. So let's try the third one, random forest, how it works. 98%. It's better too. It shows a large number here, but even it's better than cart too, and it's well classified, especially. And most of the time, when you apply a classification or a classifier on your image, and you get a result that one or two of your class or some of your classes are separated well in this classification method, but some of them are dangerous and coarse. In that time, you must export that image and keep it in your hard drive and apply the next one. And maybe the classes that were dangerous or badly classified in the previous classification will be classified very well in this classification. And the classes that they are classified so well And the first classification must expose a bad result. And the next classification, then you can select your results from each of uh, your outputs, and you can create a feasible map of classification by composing your result. So this was our today's tutorial in this video, and I wish you enjoyed these tutorials. Just keep going forward, moving forward with us from this channel, and just wait for the next videos of Google Earth Engine Explorer. At the end, I'm going to mention this. If you are going to download your classified data, just it is similar to the others. Just you can select your study area, and you can select type of your file, and it's better the zip TIF must be, or zip TIFF must be selected. So your classification bound, your coordinate system, the resolution of your raster, then you can click the download to get your data. Thanks for your attention.